Used on Montana ground station is the BN0055 9-direction Freedom IMU. You have a gyroscope, accelerometer, and a magnetometer. And the Arduino will constantly pull the IMU for data. Essentially, it just acts like a liaison between the IMU and the actual ground station laptop. For the DC4E IMU that LSU uses, you would need to read the instruction manual to be able to identify how on track you are to your balloon. That's why we have the sniper scope on our LSU ground station. One thing that's beneficial to Montana is the movement of the servos are very smooth. You have better control over how these servos operate with how you can set its speed and its acceleration rate. You can use different resolutions of positional data like the 8-bit resolution or the 16-bit resolution. It's also very easy to get the current position of your servo. We use USB to serial, so we send data, it gets sent through the COM port, and it'll go through the USB portion, which will then transmit the signal into an RS-232 signal. That's how we interface with all of our peripherals. Always make sure that the ground station is leveled, because that will alter the values your IMU is perceiving, which can greatly affect your pointing accuracy. Set elevation manually by hand. The smaller dish tends to work better, but once you start getting out to a further distance, the larger satellite dish actually outperforms the smaller dish because it has a wider range to collect signals from. When you're doing calibration with the LSU system, you set the hardware position to the default position of 180, 0. Because the way we have ours programmed is upon powering on, it will move to those positions. Be very wary of wiring on the ground station because you don't want to rip any cables or rip the Maestro out of the holster. We'll post the data of the APRS packet onto the internet. You can then actually just go to Iridium's database and then get that data. So if you have an internet connection, even if APRS packets aren't reaching us, we can then ping a website to then get our APRS data. So that's why we use the Iridium. It's always a fallback device that hasn't failed at all. The primary beacons and the secondary beacons, though, are what we're going to use as our first form of getting APRS data, because we can set the transmission rate to much faster, 7 seconds for the initial one and then 11 seconds for the secondary.